In Modules 4, 5, and 6, Warren Perez, an SIEM administrator for IBM's Managed Security Services organization in Costa Rica, will give you an overview of the architecture, basic commands, and file systems for Linux. You'll also study the Mac OS and Windows operating systems to prepare you to navigate through system threats on the desktop. You'll investigate operating system commands and specific system resources using the Pentest Monkey reference site. Pentest Monkey is one of the many tools you can use as a cybersecurity professional. Shall we continue?
Hello and welcome to Using Your Windows Lab Workspace. We're excited for you to take these next steps in your skills journey. The labs in this course and other courses provide you with a virtual, hands-on lab environment where you can boost your skills by practicing what you've learned in your course videos and readings. Your lab space, also known as a guided project or the My Cloud Workspace window, contains all the software you need to successfully complete your lab tasks. You'll also open a lab instructions file. For your best experience, we recommend displaying your lab space and instructions side by side. To access your hands-on lab, first open the item in the course for the hands-on lab. If the lab instructions display in a new tab, hover over the tab and pull the tab down onto the desktop. You can drag the window edges to resize the window to about 1/3 of the screen size. You'll return to this window later. Return to the course screen and scroll through the displayed course lab instructions. Select the checkbox to accept the Coursera Honor Code conditions. Then click the Open Tool button. Next, you'll see the Coursera Guided Project window. This window may take a moment to display. The displayed My Cloud Workspace window is divided into two panes. The left pane is named the Cloud Workspace window, and the right pane is named the Instructions window. You won't use this instructions window. Now, you can expand the Cloud Workspace pane on your screen's left side using one of two methods. Drag the vertical slider between the Cloud Workspace and the instructions pane to the far right side of the screen, or click the Expand Cloud Workspace window button displayed on the top right of the left pane. Take a moment to view your lab window. You can click the lab window resolution drop-down arrow to adjust the size of the on-screen icons in the Cloud Workspace. And next, let's adjust your browser windows to see your Cloud Workspace and lab instructions side by side. On the Cloud Workspace lab window, hover over the double box icon located in the top right of the browser window to reduce the size of your window. Move the window to the left side of the screen. Now, drag the window's right edge so that the Cloud Workspace lab window uses about 2/3 of the available desktop space. Next, select the browser window that displays your lab instructions. Drag the instructions window so that the window is to the right of the Cloud Workspace lab window. Now, you can perform the lab tasks in the Cloud Workspace window while using the lab instructions. After completing the lab, select Leave Session to close the Cloud Workspace window, then close your lab instructions using the option available for your browser. Also, before you begin, here's some extra information you need to know. Each time you connect to these labs, Coursera creates a fresh new environment. Data or files you saved in a previous session are no longer available. To avoid losing your data, plan to complete your lab tasks in a single session. These labs are timed to provide enough time to complete lab tasks, but if you leave the lab session unattended, your lab may time out or end. Now, these setup instructions used a Chrome browser within Microsoft Windows 10. Other browsers and web browsers on Mac or Linux computers may use different navigation. You're now lab ready. Let's get started.
In this video, you will learn to describe the Windows components user mode and kernel mode and how they differ.
Hi there. I'm going to talk to you today about a few quick concepts for Microsoft Windows. Let's jump right in. Microsoft Windows, developed by Microsoft Corporation, has been around for a long time. Pretty much anyone who has used a personal computer within the last 20 years probably has some experience with Windows. But really the best part about Windows is it created the first graphical user interface that we're used to. So where you can go in and use a mouse to point and click instead of having to type in commands. And it was designed for IBM compatible PCs. So obviously Macintosh and Apple devices will run their own operating system. Windows will run on what we call IBM compatible PCs. IBM, as many of you may know, created the first personal computer in the early 80s. Approximately 90% of PCs worldwide run some version of Windows, and servers as well run versions of Windows as well. So it's something that many of us are very familiar with. So there are a couple components associated with Windows, or there are a couple components that Windows uses. They have a user mode and kernel mode components. User mode is really what you see when you are opening an application, when you're using Microsoft Word, or you're surfing the web with Chrome or Firefox or anything like that. You're really accessing user mode. And there are drivers that are used by that to create that I/O, that input/output that you're leveraging when you use an application like Microsoft Word, or, as I said, a web browser. And then there's the kernel mode, which is kind of the underlying technology within Windows, where you have different processes and threads that actually control the applications that you're leveraging within Windows and within the user mode of Windows. So let's talk a little bit about the user mode. So when you start a user mode application, Windows creates what it calls a process for an application. Anybody who's gone into Task Manager can see when you have applications that are running, you will see those processes running inside the Task Manager that will tell you things like how much memory it's using, how much CPU, and CPU is your processor, how much processor it's using as you use that application. The nice thing about applications is they're really pretty segmented from each other. So when you start an application, that virtual address that is created are private. So it's segmented from other applications within the environment. So one application can't alter data that belongs to another application. Each application runs in what we call isolation, and if that application crashes, it's not going to bring down the entire operating system. It's only going to bring down that application. So other things that are going on are not affected by that crash. If we talk about kernel mode, everything that runs in kernel mode contains a single or shares a single virtual address, so that kernel mode drivers are not isolated from other drivers and from the operating system itself. So if a kernel mode driver accidentally writes to the wrong virtual address or to something else within the operating system, that data within the operating system could be compromised. So if a kernel mode driver crashes, the entire operating system would crash. So you may have seen that where you get the blue screen of death, as it's commonly called, when your operating system stops and you have to reboot. That's typically caused by a kernel mode failure or a driver within the kernel mode writing to virtual address that would cause an issue with the operating system.
In this video, you will learn to describe the NTFS and FAT file systems used by Windows.
Okay, so let's talk about the different file systems that are prevalent within Windows. And a file system is what enables applications to store and receive files on storage devices. When we're talking about storage devices in Windows, we're mostly talking about a hard drive. So what's installed in your computer, it could be a spinning platter, which is a mechanical device, or it could be a SSD, a solid state drive, which is a non-mechanical device that stores that data. Files are placed in what we call a hierarchical structure. So you may have folders within folders within folders. And the file system will specify naming conventions for files and the format for specifying the path to a file in that hierarchical or tree structure. Just for definition's sake, a file is a unit of data in the file system that a user can access or manage. So a picture file is one file. It might be a JPEG or it might be a PNG file, but that's what we consider is a file. And every file has to have a unique name in its own directory. What you'll notice is if you copy a file within a directory and paste it in the same directory, it will put a number behind that file name just to show that it's the same file, just a different copy of it. And a directory, and you may be used to having it be called a folder within Windows, is a hierarchical collection of directories and files. And we'll talk a little bit more about that as we go on. So there are really a couple different types of file systems that are used within Windows. NTFS, or New Technology File System, is the one that is most prevalent today on operating systems like Windows 10, Server 2012, and 2016. That NTFS is what most of your drives will be formatted as. NTFS has been around since 1993, and as I said, it's really the most common file system for Windows. Both end user systems as well as servers that are running Windows will run the NTFS file system. There's also another kind of operating system that was really previous to NTFS, which is called File Allocation Table, or FAT. It's a more simple file system that's been really used since the 80s. And you may see different numbers associated with that FAT operating system, or excuse me, that FAT file system. And those numbers that precede the FAT or file allocation terminology refer to the number of bits used to enumerate a file system block, so FAT 16 or FAT 32. Mostly where you will see file allocation table file system is on removable drives. So if you have a USB drive or even a CD drive that's writable, it would typically be formatted as a FAT 32 file system. And FAT 32 can be used for devices that are less than 32 gigabytes in capacity. As we saw, hard drives get bigger than that. We needed a new type of file system, and that's where the NTFS came in. And now FAT is mostly used for smaller drives and smaller removable storage devices.
In this video, you will learn to describe the Windows directory structure and how Windows handles the separation of 32-bit and 64-bit applications.
So let's look at a typical Windows directory structure. And most of you who have seen Windows before have probably seen that everything is stored on normally the C drive. I don't know why it was called the C drive, but that's just what we call it. So your main hard drive is typically called your C drive. And these are the kind of standard file structure you will see on a Windows 10 device. So you'll have some folders that are hidden, and when they're hidden, that just means that they're not accessible to the end user unless you actually go in and unhide them within the control panel. So those are folders that Microsoft says, you really don't need access to those, so we're going to hide them from you. And the main one that's hidden is called perf logs, and it holds performance logs, but typically it doesn't really hold anything. It's usually empty. But it is a folder that is one of them that's in the common directory structure off your C drive. And then you have kind of the meat of what's on the C drive, which are your program files and your program files x86. So on newer operating systems that can address more memory, we went to a 64-bit operating system. Some of you may remember that when Windows first came out, it was a Windows 3.1 was actually a 16-bit operating system, and then Windows 95 became a 32-bit operating system, and we had various versions of Windows operating systems, both 32-bit and 64-bit operating systems. And the real difference between a 32-bit and a 64-bit operating system is the amount of memory that can be addressed. As applications came out that needed more memory to run, operating systems increased their bit to 64 in order to address additional memory. 32-bit operating systems can only address 4 gigabytes of memory, and for modern applications, that's just really not enough. So with Windows 2000, we started seeing operating systems that were 64-bit, and then XP and Windows 7, and then finally with Windows 10 are 64-bit. So, and the reason I go into that level of detail is because of those two different program files. So program files will store your 64-bit applications. If you have a 32-bit operating system, you won't have a program files x86 directory because all of your applications will be installed in the program files directory. On a 64-bit edition of Windows or a 64-bit operating system, your 32-bit applications will be installed in program files x86, and 32-bit applications can run on a 64-bit operating system. They are just separated, so you'll see where they're installed differently. And then you also have a folder called program data, and those are files that are accessed by computer programs regardless of what user is logged into the system. So they're really files that the applications that you run need in order to work effectively, independent of any user that might be logged on. And then you have your user directory. This is where your user profiles are stored, and each subfolder will be a different username. So as an example, all Windows operating systems will have a public folder. So this is where end users might be able to share files. So if you have multiple people logging into a system, they can put something in public and everyone would have access to that file. And then you will have, in addition to public, under the users folder, you will have each username of people who have logged onto that system, or I should say who are authorized to log onto that system. So user files are typically stored in there. You may have lots of folders under the username directory. So you would have a documents, my documents folder, you'd have a pictures folder, a music folder. Anyone who's seen a modern Windows operating system will have noticed that. And then you will also have an app data folder. This would be like your program data folder, but for application data that is specific to an end user. So if you have a custom template within, say, Microsoft Word, it would be stored under your username and then the app data folder in order to separate it from other users who may log onto the system. And then in addition to that, you'll have your Windows system directory. And this is where Windows is actually installed here. And you'll have mainly three folders under that: your System 32, and your SysWow 64. These are file or folders that really are the core features of Windows and the Windows API. So anytime a program asks Windows to load what we call a dynamic link library file, and it doesn't specify a path, these are the folders that are searched. So this is where Windows stores all the kind of system files that are needed to run Windows and provide the graphical user interface to the end user. Your system folder stores your 16-bit DLLs, and really will be empty on 64-bit editions of Windows, but the system folder is still there on 64-bit operating systems. Your System 32 will store either 32-bit or 64-bit DLL files, and what that really will depend on whether you're on a 64-bit or 32-bit system. And then your SysWow 64 will only appear on 64-bit versions of Windows and store your 32-bit DLLs. And so that's really what you'll see when you open up a common C drive on a Windows system, either an end user system or a server system. These are the folder structure that you'll commonly see on a modern Windows operating system.
In this video, you will learn to describe the various useful keyboard shortcuts provided by Windows.
So one of the nice things about Windows is we have that graphical user interface where we can use a mouse and a keyboard and other input devices to do things within the operating system. Certainly there's a command line interface that you would also see within Linux, and command line interface is your predominant way to access a Linux or a Unix system. But with Windows, the predominant thing that most people like about Windows is that we have that graphical user interface that makes it easy for us to interact with applications, with the operating system itself, and whatever you want. So one of the things that Windows does provide are shortcuts, and those shortcuts are things that we can do on the keyboard without having to move the mouse around, or just common tasks that we can speed up by using those keyboard shortcuts. and they're typically accessed by using the Windows and another key, or the Control key and another key. They're really time-saving and helpful for things that you will do regularly within Windows. So the first one we're going to talk about is Control and the Z key, or Control plus Z, to do an undo. And really, this is independent of the application, so it will roll back your last action. Whether you've overwritten a paragraph by accident in Microsoft Word, or deleted a file you didn't mean to, this is a great keyboard to undo your last thing, because we certainly all make mistakes, and I know I've used Control Z probably more than I should, but it is really will help you if you made a mistake and want to undo your last action. Close is another one that you can use if you have a lot of windows open in your system. If you have the application or the window that is forefront in your system, if you hit Control plus W, that will close that window. And if you know, when you're in the middle of editing something, it'll bring up your prompt to save it. But that's another shortcut that can be handy as well. This is also very handy when you're copying and pasting text, especially maybe from a web page or from some source, and putting it into a document. But this will highlight everything on a particular page, and then you can take some action against it. And this is very handy, so you don't have to use your mouse and scroll all the way down on a long document or a long web page to grab everything on there. You just hit the Control plus A, and that will select everything on the document. Another one that is fairly prevalent and is helpful is Alt-Tab, which will switch your apps. So if you have, say, Chrome in the forefront of your screen and you want to move to something else, you can just hit your Alt-Tab. This will bring up a set of your windows, and you can switch to the window that you want without having to use your mouse to go to the taskbar and switch between applications. Alt plus F4 will close all your apps, and this is kind of an old school shortcut that's been around for a while, but it's very helpful. If you want to close all your apps, you can hit your Alt plus F4, and that will allow you to close everything and just exit to the Windows desktop. It will also, if you have something that needs to be saved within an application, will bring up the prompt to save it before it closes it, so you won't lose any work or anything. This one's also handy as well. If you hit the Windows button plus the D button, this will show or hide the desktop. So it's like a toggle switch. So if you have a file that you want to look at on the desktop, you can hit the Windows key plus D. That will show your desktop. You can look at the file name or do whatever you need to do, and then hit Windows D again, and this will go back to the application you were just in, so that you can go back and hide the desktop. So that's kind of a helpful shortcut for that in that regard. This will, the Win left arrow and the Win right arrow will move a window to one side of the screen, depending on which arrow you hit. So if you have a window that is not taking up your full screen and you want to move it to one side or another, so you can look at two windows at one time, using the Windows left or right arrow will snap it to one side or the other of the monitor and just give you more real estate to look at multiple windows at one time. Helps you keep things organized. And this Windows plus the tab will open the task view. This is something nice because it will show you a thumbnail of all the applications or all your open programs on the screen, and then you can go and switch between them. So it's just a faster way to open up the to switch windows, because you can go directly to whatever application you want to by hitting that Win plus the tab button. And this one will go back and forth through your options when you have a dialog box. So if you open up a dialog box within an application, tab or shift tab will move backward and forward through those options. When you have a dialog box that has a lot of choices, you can use tab or shift tab to quickly move through those without having to scroll your mouse. And this is just a faster way to do that.
In this video, you will learn to describe various useful Windows keyboard shortcuts.
F2 if you highlight a file and hit F2, that will actually give you the option to rename a file, so you don't have to right click and then hit rename. You can just highlight it, hit F2, and then that will bring up the box to rename a particular file. So if you want to do that in Excel or Word or any applications that you have, that will allow you to do that. F5 is refresh. This is kind of handy when you might be editing or looking at a web page and something changes and you want to refresh that web page. This will refresh it. So if you've made a change in your File Explorer or on a web browser, that will give you the latest version of the application or the latest version of the web page. So if something has changed, you'll see it immediately without having to move a mouse to click refresh. F5 is pretty handy for that. This is a great one as well, because you get up to go run to the restroom, you get up to go get a cup of coffee, whatever, but good security practices, you always want to lock your computer. Certainly you trust the people you work with, and you trust your family members, but it's always a good security practice. I even do this at home when I'm by myself. It's just a habit now. When I get up from my computer, I hit the Windows L key, and that will automatically lock your computer, so that when you come back down, you can use your fingerprint, type in your password, use your face, whatever your methodology is for unlocking your computer. The Windows and L button will quickly lock it to keep it more secure, and it is a good security practice to do regardless of where you are. The Windows plus I key will open your settings. So this is mostly for Windows settings. So if you're in your desktop or actually in any application, you hit the Windows plus I, and that will bring up the settings dialog for Windows. And you can also use the Windows plus A to open up your what's called the Action Center, which will show you your notifications and access to certain settings as well. So things like your network settings or your audio settings, those can be accessed as well. So Windows plus I will open your Windows settings, and then Windows plus A will open up your notification or the Action Center, so you can dismiss those notifications, or if you want to change your speaker volume or those kind of things, you could use Windows plus A for that. This is also pretty handy if you want to search for a file or a folder within Windows. If you hit the Windows plus S key, that will bring up a search dialog, and you can choose what you want to search, whether it's a particular drive or a folder. This will allow you to bring up the search dialog much more quickly than navigating to it through Windows. This I use all the time. Printing a screenshot, if you hit the Windows plus the print screen button, there should be a print screen button on any keyboard you see, and that will allow you to basically save what's currently on your screen as a file, and it will copy that image to the clipboard. And if you don't want to do the whole screen, but you want to do a particular window, the active window will be snapshotted if you hit the Alt Windows key and the print screen button. So Windows key, the Alt button, and then the print screen button will only take a snapshot of the current active window. So if you want to show one thing but not your email that's in the background, you can use that option to just get the active window within the screen. This is really handy for diagnostic purposes. If you want to send somebody an email, you want to say, hey, here's the message I get. That window's active, you hit the Alt Windows and then the print screen, and then you get a screenshot of just that particular dialog box. You can then paste it into an email and send it off to somebody. This one is also very handy. If you hit the Control Shift plus Escape, that will open up the Task Manager. The Task Manager is where you will see what applications are running, what services are running on your Windows system, and how much memory and CPU they're taking up. And so this is handy just for diagnostic purposes as well. If you have an application that is hung, this is a way that you can go in and stop that application by just hitting the Control Shift and Escape key. That will bring up the Task Manager to allow you to do that. And then this is really on newer Windows operating systems. So Cortana is Microsoft's digital assistant, if you will, or virtual assistant. So if you want to open Cortana and ask it a question, hey, what's the weather going to be like today? You can hit your Windows C button, ask Cortana a question, and then she will be gracious enough to answer that question for you, either verbally or if she doesn't know it, go to the web and pull down information about that. So that's something that's nice that's been included with newer versions of the operating system. I think it started with Windows 8, but don't quote me on that. Okay, this is probably not as well used, but if you want to kind of clean up your screen, and put open applications in there, you can hit the Windows Control and D key, which will open what we call a virtual desktop. And then you can switch from one desktop to another, and just so to clean up your windows and give you another space to work. If you don't want to have everything cluttered on one desktop, you can open up that virtual desktop and give you some more real estate, if you will. And then in Windows, there's actually a hidden menu that is separate from the Start menu. And this is accessed by hitting the Windows plus X button. And this is a quick shortcut to get into things like the control panel, or if you want to get into some Windows system kind of commands, or anything that is not part of the Start menu, but you want to get into a command prompt or those kind of things. These can be accessed by hitting the Windows plus X key, which opens that hidden menu within the Start menu for some of those applications that you still want to use but are just not included in the Start menu anymore.
In this video, you will learn to describe what makes Linux unique as an operating system.
We're going to discuss some key concepts for Linux and the operating system. Let's start with the definition of what is Linux. Linux is an operating system. It's open source, and it's licensed under the General Public License, also called GPL. This license guarantees that the end users, basically ourselves, have the freedom to run, study, share, and modify the software. But this has one, you can study the software, you can modify it, you can share it, but as long as your modifications are also licensed under the General Public License as well, or the GPL license. Linux has some components, but there are two main components that we're going to discuss now. They are the kernel and also the shell. The kernel is basically the core of the operating system. It's designed to interact directly with the hardware itself. It manages the system and the user input-output, processes, files, memory, and devices. On top of that, we have the shell, which is like an interface designed for the user to interact directly with the kernel. On the screenshot in the middle of the slide, you will see what's also called like the CLI, or the command line interface. This is the shell for a Ubuntu system, and the user types in commands in this interface, then the kernel will perform those commands for the user.
In this video, you will learn to describe the Linux file system.
Next, we're going to discuss how Linux and the file systems was designed or is designed. Let's talk first about files and directories. Files is a basic unit of storage for data. This unit is basically stored, or pretty much stored, on a physical media such as hard drive, a thumb drive, or anything that it's designed to store information. It's represented by a dash, and we'll discuss this later on. A directory, on the other hand, it's in a special type of file. A directory has information about other files, so it's like a container for files, and it's the equivalent of folders in Windows. In Linux, it's represented by a letter D in the command line interface. In the screenshot below, or the image below, you will see the highlighted directory that are on the first letters on your left-hand side. You will see that it starts with the D. That indicates that that specific item right there, it's a directory. But you will see just above that not a copy.txt. It starts with the dash. So that indicates that specifically is a file. Linux and the directory structure is a lot different than what we're used to in Windows. Everything starts with the slash, also called the root, and everything else, it's just quote unquote attached to the slash partition, or the root partition. The slash partition, also called root, it's where every single file and directory starts from. Only the root user has right privileges under this directory, and that's supposed to be like that for security reasons. The slash partition, it's not the same as the slash root. The slash root is basically the home directory of the user root. We'll discuss home directories in a little bit. The slash bin directory, it contains binary executables, basically. Common Linux commands are found here, and we have a list there: ps, ls, ping, rep, cp, mv. We'll discuss a little bit more about basic commands in Linux in a couple of slides. The /sbin, it contains executable binaries as well, but they're more related to system maintenance tasks, like IP tables, like the reboot command, the fdisk, or the ifconfig, for example. The /etc, it's where most of the times we'll find configuration files for all the programs installed. If we have a Linux server and we install Apache on that server, for the configuration of that specific service, you will go to /etc/Apache, and you will find all the configuration files on that directory for specific applications. The /var, it's in a specific partition designed to hold files that grow or change constantly. It's referred as variable files. And a perfect example for these are logs. They're usually found under /var/log. So all the applications, or most of the applications that you will find out there, will create their logs under under /var/log. The /tmp partition, it contains temporary files. So anything that you store under /tmp will get deleted when the system reboots. This is not meant to hold files like any other partition will do. Anything that is stored under /tmp, whenever the system reboots, will get deleted. The /home partition, it's the home directory for all the users. So whenever a user is created and it creates a home directory, you will find it under /home. This is designed to store personal files for each individual user. And this specific partition will only have privileges for these specific users. So let's say I created a user called Warren. That will be on the home directory for that user will be under /home/Warren, and only Warren will be able to edit or read files from that specific directory. Another important partition is the /boot partition. It contains bootloader files. This partition is specifically used during boot time. And now that we talk about boot time, we also have different run levels that Unix or Linux uses for specific tasks or specific scenarios. The run level 0, it's basically sort of a shutdown for the system. It halts the system, and all the services are stopped, and the system will not be rebooted after a run level 0 is executed in the system. We also have run level 1. This is a run level where only one user can use the system. It does not have network capabilities. This is for maintenance specifically done on the OS directly. We also have the multi-user with no network support. That will be run level number 2. It's also used for maintenance and system testing specifically. We also have run level 3, which is a multi-user with also network support. This will be if, for example, we have a server with only no graphical interface, just basic CLI command interface. This is where that specific server will run at. It will be run level 4. It has no graphical interface. It's a text mode only, but it has network support and all the necessary services running for that specific server. We have run level 4. It's a custom mode. It's used by system administrators, and it could be customized for specific needs. Run level 5, it's a graphical interface, also called X11. It's similar to run level 3 with the exception that it has a graphical login and a graphical interface for the user. And finally, we got run level 6 that basically indicates the system that it has to reboot and reload every service running on the system.
In this video, you will learn what these useful Linux commands do.
Now we're going to discuss some basic commands on the Linux operating system. We have a list of basic commands, and we're going to go one by one. First of all, we have the cd, or the change directory command. This is basically a command used to change the directories of a user. These commands are all based on a text mode, like the CLI, for example, interface. So if you want to move from /home to /bin, you will use the command cd. The CP, it's the command used to copy files or directories. For directory, you will have to use special flags like the -r or recursive. Since directories have multiple files or directories inside of them, you have to use a CP command together with the flag that tells the copy command to do the copy recursively inside directories. The move command, it's similar to the copy or the CP command, but in this instance, the MD or the move command will move directories from one place to another place. The ls command, it's used to list information related to files and directory, like owners and privileges, for example, and we'll see this in a little bit. The df command, it's used to display file system disk space. So if you want to know how the partitions are doing as regarding disk space, we could use the df command, and that will show us and print us information related to disk usage. The kill command, it's used to quote-unquote kill or stop an executing process. So if you have an executing process, for example, Apache running in the background and you want to stop it, you could use the kill command specifically to kill that specific process or service. The rm command, it removes files or directories. You will need to specify the recursively or the recursive flag on that specific command if you want to delete directories. The rm can delete both files and directories, but we also have the rmdir, which basically will remove directories, but it has to be an empty directory to be able to be deleted. We also have the cat command. It's short for concatenate. You can combine several files into one, but it's also very useful if you want to see the content of a file. If you want to, for example, cat, then text file, it would show you all the information inside that file in a command line interface. We also have the make directory command, or the mkdir. It creates a new directory, an empty directory gets created. So basically, you just type in mkdir and make dir and the name of the directory you want to create. The ifconfig, it's used to view or configure network interfaces. So whenever you need to check the network configuration of a Linux system, you can use the ifconfig command, and it will print you on the command line interface the information related to specific network cards or all the network cards installed in the system. The locate command is very useful if you want to search for the location of files. This command uses an internal database that needs to be updated, and for updating the database, you will need to use the update db command. The tail command, it's also used to view the last 10 lines by default of a text file. You could also combine the tail command with the -n, and you could use tail -n and then specify the number of lines that you want to see on that specific file. You could also use the flag -f, and that will give you a real-time view or any file. This is very useful if you're reviewing log files, for example, that they change constantly. So you can use the tail -f, and that will pretty much give you a real-time view of that specific file. The less command, it's a command used to view huge log files. It does not load the full file while opening. It just basically loads the file as you move down the file. The more command, it's also used to display text, and this does it one screen at a time. So, for example, if you wanna scroll through a big file, it will do it one screen at a time. So if you scroll down on a file, it will scroll down the size of the command line interface at a time, basically. The nano command, it's a text editor. It's used to edit files. You could type in commands. You could delete information from the file. It's just basically like a Word program for the command line interface. We also have the ch mode or the change mode command. This is a very useful command used to change the privileges or the permissions on files and directories. We'll discuss this a little bit further.
In this video, you will learn to describe the basic Linux file and directory permission structure.
Now let's talk about permissions, both for files and directories. In Linux specifically, we have three quote-unquote groups that can own a file. They are the user, basically the owner of the file, the group, it's just like the group that owns the files as well, and everybody. That means the rest of the people that can use the file, or the rest of the users that are not the user or inside the specific group. If you turn your attention to the last image on this specific slide, you will see that W. Albert is the user of that specific file. Then you have support, which is the group that owns that file as well. And those two together, the user and the group, basically make up for the owners of that specific file. For each specific group, there are also three types of permissions that you can assign, with three basic permission types, right? For this specific course, we're going to discuss these three basic permissions. They're the read, the write, and the execute. These permissions have a octal value or a number, say 4, 2, and 1, but we also can assign binary numbers to these specific files. In this case, read has a value of 4 or 100 on binary, which is 4 in binary. Write has a value of 2, which is 010, which is basically 2 in binary. And execute has 1, which in binary is 001. Again, if you turn your attention to the last image on this slide, you will see on your left the file type, which is basically a file that it's indicated by a dash. And then we have permissions. We have 3 sets of permissions, and all of those have 3 specific permissions. The first set of 3 letters, it's for the user. We can tell from this image that the user has read, write, and execute permissions. On the second set of 3 letters, we can see that the group has only read permission and execute permissions. It does not have, a write permission. You can tell that by the dash. That means that that specific permission is not allowed in this group. And for the others or everybody else, we have no permissions at all. Here are some representations of what we just discussed. The octal value of the permission, 0 means no permission, 1 means that you can execute, 2 means that you can write. And you can also add those two. For example, if you add the execute permission in the write, it will give you 3, meaning write and execute. You have 4, for example, it means that you can read the file. You could also use 4 and 1, which means that you can read it and write it. Read it and execute it, I'm sorry. 6 means that you can read it and write it. 7 means that you could pretty much do everything on that specific file, read, write, and execute. On the right side of the screen, you can see another representation of how those permissions are added. For the owner permission, we have a 7, meaning we have 4 for the read, 2 for the write, and 1 for the execute. This means that the bit for the read is 1, the write it's also 1, and the execute it's 1. So we have binary 3 ones, 1, 1, 1, that basically translates into a 7. For the group permission, we have 4, 2, and 1. That adds up to 5, meaning we have 4 for the read, 2 for the write, and 1 for the execute. And since we have, on top of the group permissions, you see that it has read, write, and execute, but the write has a dash. That means that we do not have that permission set up. So if you add 4 from the read and 1 from the execute, you will end up having 5. And that's where that number derives from. On the user permission, or the rest of the everybody, or also called others, we only have the read permission, and we have a dash on the right, and then the execute. That means we only have a permission of 4 for the rest of the users. These permissions are not set in stone. They can be changed, they can be modified, and that's where we use the ch mode or the change mode command. And this specific command, it's used as follows. Change mode, then we have the permissions that can be set as numbers. For example, 755, meaning 7 for the user, 5 for the group, and the other 5 will be for the rest, everybody or the others, and then followed by the file name or directory. We could also be more specific on how those permissions are set. So you will use the change mode command. U stands for the user, equals, and then the permissions that we want to give to that specific user, meaning R and W, it's read and write. G stands for group. We're only giving read permissions for the group. And O stands for others, or everybody, or the rest of the users. And for this specific example, we are only giving read permissions to the rest of the users. Then that will be followed by the file name that we edited or the directory that we edited. In Linux, we can also change the owner, or the group owner, or the user that owns the specific file directory. For this specific purpose, we'll use the chown command or the chown command. For this command, we'll type in chown, followed by the user, a colon, the group, and then the file name or the directory that we are modifying. On this specific case, if you draw your attention to the image below the command, you will see that W. Albert owns this file as well as support. If we want to modify that for the file name test, we'll use the chown command followed by, let's say, root, colon root, followed by the name of the file, in this case, test, and that command will change the owner and the group of the file name test to root and root. So the user root will own the file as well as the group name root will own the file.
In this video, we'll learn about where to find hardware and software specifications, as well as how to see all current activity, as well as where to locate any log files. Let's get started. The most basic place to start in gathering any information about a macOS operating system is to look within the About My Mac menu setting. It's the first option under the Apple menu, and on the overview screen, we'll provide a general overview of the hardware specifications, including the make and model, processor, memory, graphics, and the serial number of the device. There are 4 other tabs within About My Mac: Displays, Storage, Support, and Service. Displays is pretty self-explanatory, just lets you know what type of displays are plugged in. Storage will show you the internal storage capacity, as well as the distribution of how much media of any given type is on there. So it'll say there are 30 gigs of videos, 15 gigs of documents, and 100 gigs of photos. The support tab will link to useful links on apple.com for self-help, and the service will let you check warranty status and contact AppleCare if needed. Back on the Overview tab, there's a System Report button, which will launch the System Information application. This will actually host a much higher level detail of every piece of hardware, network interface, and software that is recognized by macOS, and of course is installed on this specific Mac. Useful information here can be found regarding what devices are connected or installed on the Mac. You could also see what software is installed under what versions, as well as any drivers that exist on the computer. There's also a section for diagnostic logs that specific applications will report to. System information is a great high-level overview of information, but if you want to get a current snapshot of what's happening, we'll need to look at Activity Monitor. Activity Monitor is the best way to get real-time information about everything that's actively happening. By default, Activity Monitor will open up to the CPU window or tab. What this will do is it'll show you every active process and application that's open. This is very similar to Task Manager within Windows. Also 4 other tabs: Memory, Energy, Disk, and Network, which, just like CPU, show each active process. For memory, it shows every process that's consuming the memory and what percentage of the memory it's consuming. Same with energy, disk space, and network activity. Activity Monitor is especially useful if you're looking to capture any volatile data that might not be there when you reboot. So If you need to capture exactly what's on the computer at this time, Activity Monitor is definitely one of the places to go. The last utility is Console. It's found in the Utilities folder and is macOS's application for logging any and all information. As you can see on the left-hand side, it conveniently categorizes the reports into different areas, such as application crashes or hangs with the spin reports, any log reporting, diagnostic reports, Mac analytic data, and the system log. What's nice here is that you can search for pretty much anything specifically if you're looking to pinpoint. If you're looking to monitor something, you can clear everything, or you can just hit the Now button, which will take you to the most current point in time where you can begin monitoring any specific log that you need. So between the system report, Activity Monitor, and the console logs, you should be able to audit everything that is currently on the computer and actively going. In this video, we'll be learning about the various security settings within macOS. Let's get started. All of the settings we'll be discussing in this video are found within the System Preferences in macOS. System Preferences can be found under the Apple menu or likely on the dock. It's the silver box with the gear in it. As you can see, there are a lot of different preferences to sort through. For the scope of this video, we'll be sticking to the ones that pertain to security and privacy. So that's where we'll start, the security and privacy settings. Within the Security and Privacy Settings window, there are 4 main tabs. When you first open it, it should be on the first, which is General. Here we can see 2 different categories of settings. The first is going to be around the administrator password. This is where you can change that. And then below that, kind of divisible by the line in the middle, is going to be Gatekeeper. It's not labeled, but this is the functionality within macOS that prevents unauthorized third-party apps from being installed. To clarify, a third-party app in this case is any application that's not installed from the Apple App Store. So if you were to just go to an internet browser and download, let's say, Google Chrome for an example, you would get a prompt saying that this is a third-party application. Are you sure you would like to do this? At which point you would have to override Gatekeeper. Now, in some circumstances, Gatekeeper might just tell you that you cannot open a DMG file, which is the disk image, the default installer file in macOS. To get around that, you can actually just right-click the file and hit Open to bypass Gatekeeper that way. The second tab is going to be the File Vault settings. File Vault is macOS's encryption, where it'll encrypt your entire hard drive. This setting specifically is for setting a password for it. This is very important because if you lose this, there is no recovering your data. The firewall settings is going to be an on or off option unless you go under the advanced settings, where you see you can block all incoming connections or whitelist specific ones with a few other options. The Privacy tab holds the most options, and as of macOS Catalina, got a massive overhaul. These settings exist so that when anything tries to access a service or application on your computer, it requires your permission to do so. So things like location services or access to your webcam camera, your microphone, input monitoring, so typing on your keyboard if they want to see key input, if they want to share your screen or share analytics or have access to your files. Every little thing here is going to need your permission. So each application will request it individually. It's not a blanket allow this for all applications. Each new time you launch that application for the first time, it will ask for settings, which many see to be a pain, but overall increases the security profile of the computer. The last thing I want to go over isn't in security and privacy, it's actually under startup disk. This is where you can see any partition that's on the internal drive as well as any connected or networked drives. You can select and restart to boot up into those drives, or you can boot into target disk mode, which turns the current active computer into an external hard drive to show up on another network device. For security settings, we'll see in the next video. We'll be learning about the recovery partition and what services it offers. Let's get started. macOS comes with a hidden partition installed that's called macOS Recovery. It essentially replaces the installation disks that come with new computers. So it does offer a version of the operating system you can install plus a few additional utilities. You can access it by restarting your Mac while holding down the R key. It may or may not ask you for an administrator password, and once it boots up, it'll present you with this screen, which is just a small window saying macOS Utilities. The four options that macOS Utilities presents you with are Restore from a Time Machine Backup, if you happen to back up your Mac that way, Reinstall macOS, which reinstalls the operating system, Get Help Online, which is a limited Safari browser window that'll let you have access to Apple support documentation, and last, Disk Utility, which helps us manage the storage on the device. What's nice about the Reinstall macOS option is that it's not an erase and install. It just replaces the OS files, which doesn't touch the user directories. So if there's any issues with the operating system, you can reinstall them with a moderate level of confidence that none of the personal data is going to be compromised. Now, always it's a good idea to have a backup, but worst case scenario, this option does exist. It should also be noted that this will reinstall the operating system that the computer shipped with, not what the most current operating system is. Let's go ahead and break down Disk Utility. Disk Utility offers a lot of functionality in managing the storage on your Mac. The things that you can do really break down into three areas. You can attempt to run first aid to resolve any issues. You can partition or create more volumes on the storage, or you can erase the drive altogether. In order to modify any of the volumes on the storage space, you'll need administrator access. And furthermore, if the disk is encrypted with File Vault, you will need the File Vault key in order to unlock the drive to be able to make modifications. In the event you wish to erase the hard drive, there will be three options for you to pick from. After the drive is erased, you get to choose how securely you would like that drive erased. On a standard erase, it's just like essentially dumping the entire contents of the storage into the trash can and hitting empty. Data recovery is still pretty viable at that point in time. However, if you choose the middle option, it is essentially writing over the data 3 times, which meets the U.S. Department of Energy standard for securely erasing magnetic media. The most secure option is writing over the data 7 times, which meets the U.S. Department of Defense 5220-22M standard. If you need even further detail about the drive itself, you can use the info button in the top right hand corner to produce a list of as much information as you could possibly get about the drive. While Disk Utility has a lot of features, more often than not, it's used to repartition any type of drive, particularly external hard drives out of the box, which don't usually work with Mac OS due to drivers. You can open it up in Disk Utility, select the drive, reformat it, which will get rid of any proprietary software, backup software that was on the disk, and you can use it as normal. Now, all of these utilities are wonderfully helpful, unless, of course, the hard drive or solid state drive has been reformatted, in which case the hidden partition that macOS Utilities exists on wouldn't be there. So what you can do in that case is what's called an internet recovery. You can access internet recovery by booting holding Option R. You'll see a little globe with a progress bar that indicates it is downloading the macOS utilities. A couple things to note here is that 1, it still will require an internet connection, which it will prompt for, and second, unlike the regular macOS utilities, which installs the operating system that came with the Mac, internet recovery will install the latest version that is compatible with your Mac. And that'll do it for macOS recovery options. We'll see you in the next video.